Alright guys, I want to show you two different types of problems. You've probably gotten pretty good solving some of the ones where you have to raise to the reciprocal. Sometimes though, when we have to raise to the reciprocal, there is one or two other types of things that we'll have to do. Let's first look at this example and think about how it is different from the ones we've seen. The majority of the ones we've seen have had 2x plus 7 to the 1/2 equals 2, but not this piece right here. And we may have done a couple, but just to review, what we want to do is take this x and move it to that side. I put the x first just because we normally do, and now I've isolated my rational exponent. Now is when we take this and raise it to the reciprocal. I also have to do that over here. On this left side, it just cancels out. On the right side, however, a lot of people will be tempted to say that this equals x squared plus 4. But it does not, and it never will. Because when you square something, it means multiply by itself, which means x plus 2 times x plus 2. You guys know how to do this very well. We've got to now distribute, which will give us x squared plus 2x plus 2x plus 4. So we don't end up with just a binomial because we have these middle terms here. This will give us 2x plus 7 equals x squared plus 4x plus 4. This is what I call a quadratic trinomial. When we were in the quadratics chapter, we always wanted to set this equal to 0. So I need to take these two terms and move them over here. I notice the 7 and the 4 are like terms, and those will go together, and that the 2x and the 4x are like terms and will go together. That's going to give me 0 equals x squared plus 2x minus 3. The key here is asking yourself the question, what two numbers multiply to AC and add to B? This is B, A is 1, and C is negative 3. We know it's x times x because that is the square root of x. That's where we got the x squared. The two numbers that multiply to negative 3 and add to positive 2 are positive 3 and minus 1. Now I've got the product of two linear binomials, and one of the two quantities has to equal 0. So you can set it up as x plus 3, your first factor, equaling 0, or x minus 1 equaling 0. That's going to give you a final answer of x equals negative 3, or x equals 1. So the key here is that this, right here, we have to remember how to factor. And it's not just factoring, because that's this step, right here, but solve by factoring, which means to get x by itself. This is another type of problem we see very commonly. The two places where people will get caught up are right here, doing this, or right here, and they'll just get stuck. But we want to remember it's a binomial times a binomial, and that we have to ask ourselves this question, what two numbers multiply to AC and add to B? Now over on this side, what we notice is different is that we have two rational exponents. The key here will be to get both of them being a whole number first. It works if you don't do it this way, but this will be the easiest and the most efficient way. Take this and raise it to the fourth. If I only raised it to this reciprocal, then I would have ended up with 1/2 here. And it's just nicer if we can get rid of both fractions at once. These two will cancel out and give us x plus 14. These don't cancel out, but they do give us 4/2, which is just 2. So that's going to be 2x squared. Now, your instinct might be to take the square root, but I can't take this square root, so what I do is I follow these steps over here and set it equal to 0. Minus x minus 14. Now I have to ask myself the question, what two numbers multiply to AC and add to B? Well, here AC equals -28. And if I look at my factors of -28, I have 7, I have 4, and I have 7 and 4, I have 14 and 2, I have 28 and 1. One of the things that's going to happen there is that you actually need to do something different here. So what I noticed is and this is the common mistake, is that I decided not to keep my parentheses, which made this step slightly incorrect. Because if I do 2x squared, what I should get is 4x squared. That will change my AC to -56. Again, that's probably the area where most people will get caught on this problem. They'll see this and they'll say it's 2x squared. We've now fixed the common problem. We're going to go back to here and talk about this. What two numbers multiply to -56 and add to -1? Those numbers happen to be -8 and +7. Now, we're going to use what's called the Berry method to factor this, which means that we don't put 2x and 2x, we put 4x and 4x. Now we look at both of these and we decide what one can be factored. Well, this can be divided by 2. That's going to give me 2x minus 4 times 4x plus 7. And then, so we find that we see the 2 as a factor, but then we can look again and say, hey, there's still a 2 as a factor. So we'll do it one more time and end up with x minus 2 is 4x plus 7. Now this could be done in one step by, instead of dividing by 2 twice, dividing by 4. At this point, we are down to what we had over here, and we can say either x minus 2 equals 0, which means that x equals 2, or 4x plus 7 equals 0. Subtract 7 and divide by 4, and I'm going to advise you to leave it as an improper fraction. And so that is going to give us -7 over 4, minus 7 divided by 4. These are two different types of problems that you will see on your homework tonight, and hopefully this will help you.